Dear doctoral students, welcome to our fourth lecture, which is in fact the last one, and as those before this one, it will take 4 parts to complete. Today I will speak about errors in research, because we are human and we do mistakes. The problem is that we have to also find methods how to resolve them and explain the role of errors in our research. In fact, it's generally presumed that about 1/2 of research results are false results, wrong results, and it's very difficult to reduce this number for various reasons. I will mention some of those today. So, first we have to understand that science is error-prone, which means errors may happen often because, in particular, this is a new way of reasoning. We are on the edge of human knowledge, and that's no one can correct it properly. Sometimes we have to just believe that it's correct. Then, history of science shows many failures, and even those failures move the science ahead. So, Karl Popper, a well-known philosopher of previous century, have found that even those failures are progressive, and he declares that every science should be falsifiable. And we point then, in the end, to some sources of unwanted errors, because I truly believe that you are not going to make your errors intentionally. So, what are meanings of errors in science? Because they may happen from different reasons and they have different sources. So first, many of those mistakes, most of them, are unintentional, which means you use wrong data, which means not intentionally wrong, but simply because they are affected from different directions. Devices are not absolutely correct, people don't respond always truly, and so on and so on. And finally, to this category, your imperfect reasoning belong, because again, we have to control what we say, and naturally it may happen that we may get mistake in it. Then sometimes even correct results are presumed to be false, simply because they go against the mainstream. So, as such, they are refused by reviewers of academic journals, saying it cannot be true because it goes against everything. Or even if this is accepted and appears in the journal, it's not accepted by community. The community is conservative and still may consider the idea wrong. And as such, it is then never implemented, which hinder further progress. And so the idea is we have to accept this situation which is here and say, okay, every error, or what is considered as an error, is in fact a trial to revert our current knowledge. And this is the way how Karl Popper explained it. He said falsification moves science forward. So let's show an example of this. Look, what is our knowledge? As I said before, it's true, which is undisputable, justified, considered by community as a true knowledge, and finally believed, in which we as individuals hope that this is correct. I showed this slide in my first lecture, so I will not speak more about it, but we have to understand that this is the basic position we always face to. And look what happened in history. Copernicus' heliocentric system was refused by community in the beginning, and it took dozens of years until it was accepted. Giordano Bruno believed in ETs, extraterrestrial. That time it looked like a very strange idea. Now we more and more believe this might be true. This is not been proved yet. Or even well-known scientists are making such mistakes. Black holes are the consequences of Einstein's theory of relativity and gravity. But he didn't believe in them. He was saying it cannot be true. And all his life he refused that black holes exist. The fact now we know is absolutely correct. So what happens in present? There are still people who believe that Earth is flat. There are still people who believe that those extraterrestrial personalities control our destiny. They control our Earth and life on it. And this is fun. There is a theory which seems to be correct, which says that except to our universe, there are plenty other universes parallel to the others. Theory says yes, it's possible. Naturally, very few people believed in that. So, how our knowledge develops and what happens, how sort of errors we can do during this history. First, we have to collect evidence. This is a very typical for any dissertation. In the beginning, you collect evidence to prove something, to demonstrate something. And naturally, if you do so, you can make errors because you collect wrong data, or data you will find are mistaken. Well-known history is about spinach. Many people still believe that spinach contains a lot of iron. But it was proved that even in 18th century people knew that there was a mistake in this measurement. And the mistake in measurement caused that it was 10 times more than in any other planet. It was proved as wrong, but people still believe in that. Similarly, what the people did, they make a wrong decision based on wrong data, accepted data. And so what we have to do is to build a consistent system of statements. For example, we can ask, why should be spinach 10 times more rich in iron than any other plant? What's the reason? And then we see we have to doubt this fact. Then we do semi-formal conclusions. So based on the data, we do some conclusion. This question which asks us, okay, is it true this fact about spinach? It's semi-formal conclusion. It's not true conclusion. We don't know. We question it. But we say, okay, we have to ask, we have to research this. And then we can create something which is called axiomatic system, which means system of ideas which seems to be correct. It doesn't mean that they are correct, but the facts fit together and create something new. And the third level, we then compare our previous knowledge with our new system of knowledge, this new axiomatic system, and ask, are those two systems, old one and new one, compatible? When yes, and when no, because some of those facts can be true for both, some not. So then we have to ask, if not, why they don't fit together, and which one is better. In principle, better in science means explains more than the other one. So more facts are explained by them. And then we test the validity of the new knowledge, which means by Karl Popper that good theory must allow its own falsification. So it must be so solid that if you find new facts, you can revert those previous ones. And which means also to reveal its prediction power, because in fact what we do with science is we build it because we would like to predict something. So, new and good theory, new and good observation, first reverse the antiquated theories and shows reality of our current knowledge. So we should be aware that every future theory will revert what we know. We cannot take what we know as something absolute, something absolutely true. And also it makes appeal to our common sense in both sides, positive and negative. In positive side, we may be happy that we now know more. And in negative, we start considering, is it important to learn if there will be something new? So there are possibilities to take it from two sides. And naturally, all knowledge is provisional because it's relative character and constant changes. And in fact, it also means that no theory is omnipotent. No theory can cover everything. There will be new theories, and the current one is just the best combination of everything we currently know. And the main idea, if I should refer back to Karl Popper, he said,